Let's do something interesting today. Today, I'm doing something completely different that I've never done before. I'm going to show a Zoom interview I just had with Ahsoka from the Bio-Veda Academy. He's really got his stuff together, and he's been around the world building some incredible structures with whatever is available and affordable in that local area. If you get a chance, check out and subscribe to his channel. Link in the description below. There's a lot of knowledge there on alternative building materials and heating and cooling systems for greenhouses and residential houses. Hope you enjoy watching this as much as I enjoyed making it.
Hello, Scott. Welcome. Thank you for taking some time to meet with me. How are you doing?
Absolutely fantastic. It's about 11 a.m. here in Canada. I understand you're in Northern Europe. What time is it there?
Oh, it's 8 p.m.
Well, that's not too
Yeah,
bad. That's not too
yeah,
bad.
yeah. So,
So
Scott,
some
I've been watching
background.
you.
Oh, you go ahead.
Yeah, I've been watching your channel for quite some time. Actually, you introduced me to this one guy, Sergey Yurko. I see you also subscribed to him, and I, through you, actually subscribed to a guy that's developing some interesting solar tech. So I fell in love with just you sharing knowledge about greenhouses. And what brought me actually to you is that I'm combining a greenhouse with a thermal mass home. So I'm so excited to just connect with you and ask you a few questions. You've been doing such amazing research.
Well, I have my own greenhouse. Don't get me wrong, but a lot of things that I put on the channel, I haven't done myself. That being said, I've either researched them or seen them in person, and I have incorporated a lot of it into my greenhouse, and we're building more. So that gives you some background and idea of what exactly I'm doing. The philosophy of my channel from the start has been how to do this primarily for a greenhouse, but how to do it with what I like to call ROI, or return on investment. Uh, in our climates, as you know, it gets awfully cold in winter, and the biggest concern is heating, whether it's a residence or a greenhouse or anything like that. And with heating, there's things like thermal mass, insulation, solar gain, that kind of stuff. But that being said, you can do almost anything if you have an unlimited budget. And the biggest thing that's held me back, and you see it often in my comments, is you'll get engineers or people going, "Oh my God, I can do this so much more efficiently." But you're building it at $300 a square foot. I'm trying to build something at $10 a square foot. Um, when I do a business, I don't like to put a lot of money into it until the business itself can pay for it. I mean, it's nice if you're massively profitable and you can get a glass greenhouse that's built absolutely perfect with everything on it. But I'd like to be able to build something in the middle of nowhere in a climate like we have here, where it gets down to 40 below, that works, and do it at $10 to $15 a square foot. Suddenly you have a business that you can pay off in 1 to 2 years. And that's, if you buy and build something and it takes you 20 years to pay it off, who are you working for, the bank or yourself?
Exactly.
That's been the
Scott,
philosophy of everything I've done.
I love your strategy, and I think it's the perfect strategy because I am fully there. I harvest rubbish, which can be used for building, of course, inspired by Earthships, fantastic foundations out of tires. I use earth bag predominantly, as you can see in my drawing behind, which is 10 parts earth from underneath my feet and 1 part cement. And yeah, even car windows, because those literally got a little crack on them, and they're fantastic windows. If you could put 2 of them in cob, I haven't done that. And just like yourself, some things I've done in a warmer climate, and I've just built a vault in Siberia, which was for $1,000 for all the building materials. So I'm game
That's
on
awesome.
not getting into debt. In fact, I've lost my home to a bank in South Africa after halfway into payments, 12 and a half years into payments.
Oh, that hurts.
Yeah, I didn't want to do what I was doing it when I started. Obviously, you can't plan to 30 years ahead. And I just had to walk out of it with all the investments I've done. And in fact, I've paid it already once over. But because of credit, you pay
The
the,
interest
the
and
percentage
yeah.
first and then not the capital amount. So anyway, I've lost my home previously. So I'm there with rather doing it cheap, rather starting small, less space, but you know what? It's yours on your land.
So I mean, I'll be honest, I just became familiar with your channel in the last week, and I started looking at different things on there. And I'm going to tell you, one of the things I'm so impressed with is that you looked at what's happening with Earthships, and I think you were even involved in building some of them. But on your stuff, I don't see you using the tires. I see you using earth bags, which I think is smarter. Um, I've always had a bit of an issue with the tires myself because of the amount of work that's required to stuff everything into them and put them on there. The term I like to use is you need a gaggle of hippies to put this together. And not everybody has access to this amount of free labor. And if the labor is not free, suddenly the costs that they're talking about go through the roof. So I
Yeah,
love the earth bags and what you're doing. They're much simpler. You can do them with one or two people. You can set the depth, like how wide the earth bag is, to whatever you want based upon what kind of earth bag you're doing. All in all, you took what I thought was some of the best aspects of the Earthships and incorporated it into what you're doing to make it more cost effective and better.
yeah. Wow. Thanks for that comment. Actually, it's very true what you said, because I've done 4 rows of tires above ground plus 1 row as a foundation, and I gave up. And that wasn't nearly
I
like
can
an
see that.
800 square, not wasn't an 800 square footer like, or 1,000 square foot Earthship. I gave up because I'm 41. I did have COVID, so my lungs are not of, whatever people's. Maybe we should cut this out, but you know what I mean. I had a bit
I
of
get
a
that.
illness in my lungs, and I can't breathe just as much as I used to before that. And the problem with pounding tires is that you have to bend down with a sledgehammer, and
It's a lot of work.
only can do 4 tires per day.
And you
Only
can't
4.
automate it. That's the worst part, is you actually can't get some sort of hydraulic system to do this unless you want to spend $1 million designing something. It's that complicated. It's got to be done manually.
Yeah, there was a system, mind you. One needs to, maybe we can find that little video shot, but the guy picked up one of those what is it, stomping devices, I don't know what's it called, and he picked it up on a backhoe and he moved it over the tire, and then he got them
It's
pretty quick
massively
that way, but
complicated.
still. Where's the backhoe? I don't have a backhoe. So I'm developing homes as simple, with low-tech tools, with, just as you said, 1 or 2 guys. 2 guys is a good team, because it really speeds you
And
4
that's
times.
reality. Most people have access to them and their wife, or them and their brother, or their friend, or something like that, and they don't have access to a gaggle of hippies to help them put something together.
Yeah.
Like,
So
my purpose since the beginning has
Yeah.
actually been cost, not eco-friendly. Not that I'm against eco-friendly, but if you can't feed your family, eco comes second after being able to build it and do it affordably.
It's very interesting that you said that, because I find that people from northern cold climate think somewhat differently. Because if you're in California or South Africa, where planting season is 9 months of the year, you kind of like take it easy, and you like, let's zen on it, let's meditate, let's connect with the universe's highest being. But here, before you know it, boom, everything is in frost, water is frozen, ground is frozen, you hit a spade with the ground, it bounces off.
Winter is
like,
coming.
Oh my God. Say that again?
It's like Game of Thrones, where the theme is winter is coming.
Yeah.
You live around
I
that.
call it the hardcore reality check. So yeah, it's different.
So let's get into some of the ideas that you've been going on. I mean, I sent you a list of a couple of things I'd like to discuss, and I think we're on very similar pages to a lot of this, but I love what you're doing.
With pleasure. Can you see this screen?
Yes, and the stuff you're doing is so visually appealing. It's fantastic.
Yeah, I kind of combined, I could say, an Earthship with domes and Gaudi. Really love the curves, and I'm not going to go, if we have time, I can go back into the rest of the presentation, how I started with stretch spandex and all of that, but I really want to get into the meat of bioarchitecture. So basically, yeah, I learned at Cal Earth, learned at Dome Gaia with aircrete, and I kind of been doing like these curves and traveling the world with large windows, designing homes with large windows out of these 2 methods. And then, something dawned on me, but what happens if we attach a bit of a greenhouse? I've always been fascinated with Earthships. In fact, I went to Taos in 2011 and in 2013. I built, had the opportunity to build with Mike Reynolds. So I thought, well, what happens if we start, you know, here you can see a bit of my fabric days. I was actually testing quarter geodesic dome through my exhibition design. What happens if we attach a bit of a greenhouse to a vaulted space, especially if it's made of mass? So this is some of my first earlier designs, and then I've made some models. Just like yourself, I haven't built a full-scaled Earthship yet. I've built a vault, which I'll show you, and I've built some homes in warm climates. But mainly designs and through models, I find very good to actually do these little 1 to 10 scale, because you realize that this fancy thing on top is not going to work. It all flops down. So models are great. So yeah, it's just been incorporating geodesics because they're easy to build. Geodesic domes are those low-tech things that
give you an idea of the 2 greenhouses I've built here. I built one that's a dome. You may have seen it in some of my videos, but I also started building a Quonset hut type one, and both were built off of plans from a guy out of England named Paul Robinson. I don't know if you're familiar with him.
Yes.
So he's got some incredible stuff online for building domes and things like that. But here's the interesting thing on my dome versus my Quonset hut. My dome has been up, I don't know, 4 or 5 years now. I'm over 300 pounds. I'm 6'3". I'm a big bugger. And I can hang off the top of my dome. And I only built it with small, thin electrical conduit because I got it on, they had a blowout sale at Home Depot one day and I got it crazy cheap. And this isn't really thick material or anything like that. But in the dome, I can hang off of it. It'll hold that much strength. But if I go to the Quonset hut, it doesn't even hold itself up. Like I use the plans from Paul.
And that's a thing for cold climate. We have to consider the snow load. The snow load can be so heavy that I've seen some of these greenhouses literally squashed after a big snowfall. The next morning, they're all lying flat.
Winds. I mean, I'm of the opinion if you can't build something that can withstand a 60-mile-an-hour, 100-kilometer-an-hour wind, there's no point in having it because you're going to get a bad day and goodbye greenhouse. So, I mean, I'm a fan of the Quonset hut idea. Don't get me wrong. But it needs more material in structure to get the same strength as a dome. Quite a bit more.
Yes, exactly. So that's why I love geodesic domes, but I don't use them as a full dome. I use them as a half a quarter of a sphere. So you actually,
I love what you're doing. It's beautiful.
Yeah. So there's myself and my wife. We're digging a foundation. So eventually it gets drawn on the ground. And here I'm developing something interesting. It's an air channel because in order for these homes to work, I need to be able to, I'll show you just now in one of the next drawings. I'm basically taking the hot air from the greenhouse, and instead of dumping it like an Earthship does, I want to take some of that heat into the berm burial. So I'm testing different things, but what this plastic roll is here, I haven't tested it yet, is basically we're going to blow it up on a bungee jumping fan, and I'm going to attach it with a mesh, with a stucco type of mesh. I think it's a fiberglass mesh on this foundation, on the snake foundation made of a sandbag with some nails to the side. And then I'm going to use a hopper gun to spray a thin layer of cement and sand mix over this blown up plastic chute with the mesh, and to create a channel that's a catenary shape arch. Does that make sense?
Yeah, somewhat.
Okay, so basically I'm going to create my own channel. Otherwise, what else are we going to use? Stainless steel or some other expensive tubing? I want to be able to design my own tubing that can take even the heat. If I want to be able to send hot air down through the, through the floor, I can from the stove.
So I like that. The one issue I've had with that, and I've kind of moved away from the idea myself in designs of having the heat underneath the greenhouse, because cooling becomes an issue in summer if you've got your heat underneath you.
Yes.
There seems to be this idea among a lot of greenhouse builders on the passive greenhouses that we got to take whatever heat the sun gives us inside the greenhouse and use it. And I've kind of come to the idea that I'd rather regulate the heat and blow it out if I have too much, and have my thermal battery outside the house, even though it might need to be slightly bigger.
But the thermal The thermal
I
battery,
like
Scott,
the
is outside the house. It's something that I'm experimenting with a different air. That air
absolutely.
channel that I was showing you is for fire. It's for fire in winter time, so I could stoke the
Right.
fire low and have the heat go underneath the floor, warming
Yeah,
up
and hold the
30
thermal
degrees
mass for
of
that.
mass.
The biggest problem I've always had, it's close to what a climate battery is, but it works for what you're doing. Like, I mean, and I think you're on the right path there. I mean, for me, the large thermal battery that I want to draw for heat, I've always felt I like. Are you familiar with Drake Landing in Alberta?
No,
It's a
no.
housing community. It's something you should maybe look up. What they did was they took 55 homes and they put solar collectors, thermal solar collectors on all the garages, and sent it all to one central big borehole that they dug into the ground and heated it up. And they use it seasonally, storing the heat to heat all the homes. And they're actually able to get something like 99% of all their heat now, if not 100% of it.
Okay, so Scott, here is the first question.
Yeah.
Does that borehole have to be insulated from outside of that outside ground, all
Yes
around?
and no.
So,
What Drake Landing did is the borehole is so big that it doesn't necessarily need, because it's doing 55 homes and the width and girth, the insulation of insulating it from the ground is done just by its size itself. When doing it for an
okay,
individual home, I agree with you on the idea that it needs to be insulated, but I also think you're on the right path in using things like aircrete. A lot of people will use aircrete for construction, and don't get me wrong, I think it's good and it works. But to me, the biggest value in aircrete is insulation.
yes, yes, yes. And there is a fellow on YouTube that started combining polystyrene, shredded polystyrene that he gets for free from towns, and he shreds
Seen
it
that.
with this lawnmower upside down, and he mixes it with aircrete and gets tremendous R value, literally for nothing.
Yeah,
This is, by the way, the vault that I built for $1,000 on material. This whole thing
that's
cost me
fabulous.
$1,000, and it can take
That's fabulous.
10 tons per square meter. C-grade wood, which we shaved ourselves, logs, all those logs we got out of the forest, and those were dry logs. We didn't kill one tree. Well, for the walls, the logs were taken dry and dead, and we cleaned them up. Yeah. So basically, just to explain the concept, can you see the slide? This
Yeah,
bottom
I
right,
see
can
these.
you see? So it's a 3 designs back already. But basically, we're gonna take the hot air from the highest point, channel
Yeah.
it down using that fat pipe. It comes down to a blue barrel, a 200-liter barrel, and spreads underneath the greenhouses. And that's what I'll consider what you said about not overheating the greenhouses. There is a septic. It heats up the septic, where septic likes being warm, being bacteria and stuff. And even short of it, basically, all of those is taken to a burial berm behind the home. So these tires, are still my old design, as I said, but these tires
Yeah.
basically, the burial is held up until this wall. All of this is buried, and that's obviously insulated. And I'll show you a little pencil sketch now so you can see. But and then these are the two cold pipes, making sure that the cold air comes in. But that's exactly like an Earthship system, and the cold air comes in insulation, so that warmth of the berm is not heating our cold
Yeah.
pipes.
Now that
Yeah.
you've really got this down nicely on a lot of things that you're doing.
So,
To
and
get into
to take what
go
you
ahead.
said, about not overheating the greenhouse, I want to have basically a black pipe somewhere up at the top of the greenhouse, and channel that air through into the burial. And one last thing I didn't show you, because the question is, are you going to be running a fan all day long? No, I'm not. I'm planning to use 2 solar tubes. So if you look at my hands, like a mirror behind, like some flexi mirror. In front is the polycarbonate, yeah, okay, and
Yeah.
then that 6 meter, 1 foot diameter, 30 centimeter diameter black pipe, yeah, that runs from top to bottom there. And basically, I'm planning that if it's sized correctly, it will create a draft, because so much heat, just create a suction and pull all the warm air from the greenhouse through the burial and then we're going to exhaust it out through this, so it's going to come out nice and cool, leaving all the warmth in the burial, and the burial will stay dry, because just like the John
So
hates
that's cool.
umbrella hole, yes, insulated
Now
and dry.
I'm going to run one question with you there, though. I
Mhm.
like the idea that it's doing a natural draw and going everything on that, but how is that? Let's get back to one of my founding things that I believe in for my site is ROI. How does that? I think that'll work, but how does that compare to just sticking a fan on it to electricity?
Okay, the
I mean, which
problem
would
with
be
the
more
fan
efficient
is
and
that
cost-
we're always reliant on tech, and I like the idea of a passive home. And passive home is not a fan going
Okay, that
on
makes
and off
sense.
all the time. We will start it with a fan. There is a fan, that little worm here, this little red worm
Yeah, yeah.
here. That's that little nugget, like an egg. That's actually underneath the sauna. There it is, that little worm. Okay, that's inside the sauna, and the sauna is this constantly hot space. That's that super Adobe sandbag
So
unit inside the
let me
cylinder.
give you one thing just to consider when you're talking about natural convection. And I'm
Mhm.
going to use my house, my own house. I have a wood boiler here and radiators that we have around the house, and it works. But I can only heat my house to about -10 with the radiators unless I put a fan on them. And when I put a fan on my radiators, I'm good to -25. So it gives you an idea of
Wow.
the efficiency difference. I be that much, but it is. I mean, we live with this and we've had it for a few years now. I literally can go 15 degrees Celsius colder just by adding a small fan. And I'm not talking something major. Like the fans that I use are tiny that I add to them, but
Okay.
the
So they're not
efficiency that
taking a
it
lot
gets
of
out of it is
electricity.
massive. No. In fact, hang on one second here. I'm going to grab one and I'll show it to you. It's right here.
I'm going to stop share so I can have you on the
Sorry
screen.
about that. So I don't know if you can see this. There. This is the fan that I use because I got right outside my door is one of my blowers. You see how
So
small
what do
that
you
is?
blow that on?
I blow it on a radiator. And it's just a small little radiator and it works. Just let me put the fan down. Give me one second here. Okay, sorry about that. So it blows on. I have three different main heat register radiators. The radiators that I have actually kind of look like a baseboard, an electric baseboard, but they're really you can look them up online. They're really just a
Like
heat
a car
radiator.
radiator, like has lots of little aluminum
Exactly,
little foil.
exactly. And it has hot water going through it and heats it up. Now, it's designed to work by convection, but the efficiency and how much it puts out by adding that little fan. Sorry, my dog wants out here. Got to take care of your pooches. It's
Okay,
phenomenal.
so
Like I
what
said,
basically what you're saying is you blow any excess heat off that thing so it cools down and it gets more heated faster.
yeah, whenever it's colder, we turn the fans on. But when it's not that cold, because it kicks out so much heat, we just turn the fans off. You know,
Okay.
our system, I don't even have my house on a thermostat system. My wife likes to have the window open at night when it's not that cold, but not that cold using a wood boiler means -10 Celsius. And we produce so much extra heat, it's not a problem. But like I said, I'm just saying the amount of heat that you're going to move with a little fan. And I understand it involves technology, but a solar panel and a tiny battery will run that thing 24 hours. That isn't going to cost a huge amount
Okay,
compared to
so
the cost of.
that brings me to another challenge that I didn't speak of. Here in Northern Europe, it is overcast for 2 months of the year. So what Earthships can achieve in towers by the sun blazing through that back into that mass room, we don't have that. November and December, it's like the sun comes up
How's
at
your
10,
wind?
goes.
How's your wind?
Say it again.
How
Oh,
much
the
wind do you
wind.
get?
No, not a hell of a lot. Not a hell of a lot that we could catch that on. So if we're talking about a totally off-grid solution, look, one could put something
Yeah.
into the boiler that could create a bit of a generator. You know, that's also a possibility. But I do want to see, my system is slightly different. I don't have a radiator. I have these pipes that basically take the heat from the top of the greenhouse in summer and they channel it into this huge 200-ton excavator buried berm behind the home,
Yeah.
as you said, separate to my greenhouse. So the greenhouse, the home, and the burial. I'll show you now from top. And basically, that burial is insulated, not allowing any of the cold heat to come out. So it can only go one way. But
Right.
now I have another challenge because I'm heating up my back burial so hot my whole summer. Not so Earthship just gets blasted by the sun and it gets
Right.
heated. And Earthship dumps all the heat from the greenhouse, correct? They have this
Yeah.
huge skylight and just creates draw and it pulls the cold air through the pipe, that cold pipe metal, and then it sucks it and throws it all into the atmosphere. What I'm doing is slightly different. Yes, I'm going to have that extraction skylight on a automatic wax paraffin
Yeah, those work well.
hydraulic thing. Yeah. So when I reach like 30 Celsius, it also doesn't overcook
Yeah,
my
it
plants.
just auto
But
opens and
but instead of before that temperature, I want to take that heat and take it through into my burial. So it's not like I can use a fan to get the whole thing started. Like, in cold climate, you use sometimes a newspaper to get a cold plug out of the pipe, blast it out. So it creates a
yeah.
draw. And until then, it's just the smoke is going into your house. So it's basically create that effect, but in summer. And then when the sun is shining, okay, and then once it's rolling, I want the hot pipe to just pull that air right out. So my system is slightly different, although I love the radiator idea, and I definitely want to combine the radiator water system and my hot air in the berm system.
Don't get me wrong. I use a radiator system because of the house I got here. If you're building from scratch, you should be using radiant floors. That's my 2 cents. You start looking at the efficiency of how heat pushes out. Radiant floors are often twice or 3 times as efficient, meaning you need a lot less heat to give you the same amount of heat inside. So, and I use a radiant floor in my greenhouse, whereas my house I have radiators because I couldn't really rebuild the floors. It's amazing.
You use radiant floor in your greenhouse?
Yes, I do. I actually have a video on that and how I built it, and I did it incredibly cheap. Most people will pour concrete to do it. What I did is I poured sand, stuck the PEX tubing, which is the radiant delivery system, and then I got free sidewalk blocks and I put them on top. The sidewalk blocks basically are concrete. They heat right up because they're on the warm sand, but I didn't have to buy and pour concrete. And concrete is not cheap. I mean, if you look at pouring for a house, I mean, depending on where you are here, you're looking at $10,000-$20,000 by the time you're done with the labor and the pour and all the rest of it. And sure, you can do it yourself, and it's not that hard, but it is to do it right because it's so easy to screw up.
Yeah,
I mean, if you're just
exactly.
pouring something simple and stupid, do it yourself. But if you're pouring for a house or a garage, you get professionals to pour that.
Yeah, I got you. And $20,000, not everybody's got that just lying around.
No.
I'm
But I mean, I
planning
built
to.
mine for bugger all. I mean, I used free sidewalk blocks. The PEX was, I don't know, $100 or something.
And use a little heat pump that circulates, correct?
Yes, correct. Taco
Nice.
pump or something like that. And
I'll
they're, what are
definitely
they?
check that.
$100 to $200. They're nothing major.
Yeah, I'll definitely check that video out. I just want to finish this quickly, the little presentation. It'll also give us some okay. So basically, so that's this house design, and also obviously in order to build a home that you know warms up with the sun, you got to take the angle of the sun and your area into account. How does it affect my design? Well, I will design the ceiling at 20 degrees. So in November and December and January, there's very little sun. It's literally 9 degrees off the horizon and it's overcast most of the time. But in February, when it comes out, here's this February line. Okay, it's at 20 degrees. So I'm designing my roof at 20 degrees. So basically that February warmish sun. It's not, I mean, when the sun comes out in February, it's like -30, but it's already a bit high. So if, the sun does have a bit of warmth once it's inside the glazing, correct? So that's how it affects. And a huge mass. This is where I'm really like taking Earthships a bit. Obviously,
That's enormous.
excavated. Yeah, 3 meters.
The question I've got, well, I think you're doing it right, is that you're actually putting injecting heat into that mass, because as soon as you go beyond 2 feet, it's really hard to radiate a lot of heat into it beyond that short term. But if you're injecting that heat into that mass that size, you're on the right
Yes,
path.
that's what all of that pipe work that I'm developing. That's exactly what it's for. Another question I have for you, Scott, the skirting of insulation. I've thought of doing a skirt of insulation that goes out like this. I've seen some Canadian homes, the insulation goes straight down parallel with the foundation. With this skirt, it creates like an umbrella that I take a bit of mass around the home. What are your thoughts on that?
It works. The type of insulation you're going to put down depends upon what you have available to you. Whether one of the things I've done with that is when they're tearing down commercial buildings, you can get styrofoam, big styrofoam sheets cheap. I mean, styrofoam sheets that cost $60-80, a 4x8 sheet here, I've been able to get for $5 used. And what do you care if you're sticking it in the ground if it's used or new for styrofoam?
But what's your thought on going parallel down with the foundation, just right next to the foundation, or grabbing a bit of earth extra around you?
I think you need to be close to the foundation and insulate it going down. Where you live, in my climate, you got to go down 6 to 8 feet, but it's worth it. There's a lot of cold that'll come in through the ground, a lot.
So what you're saying is, if I go with the skirt going at an angle, I'll have the cold climb underneath that skirt. Is that what you're saying?
Think of it as just a fence, and it keeps the cold on one side and the warmer material underground on the other. You're going to prevent 10 degrees Celsius loss or more, depending upon how cold your ground gets.
Okay, and the next question, Scott.
Further south, it's not as much an issue.
If I go, let's say, fine, 3, 4, 5 feet down, do I still insulate underneath the floor of my home, or should I? Because there's mixed thoughts. Because if I don't insulate,
where you're going down is to the frost line. So below the frost line, it's going to be 0, and then 5, 10, whatever your ground temperature is where you live.
Okay.
Does that make sense? So what
Yeah,
you're
but
doing
do I
is
insulate underneath the home or just around the perimeter?
if you want to go underneath, only if you're heating underneath the home and you want to hold that heat. If
Gotcha.
you're fine with 5, 10 degrees below, once again, it depends on your heating system and how much heat you want to save. You can have 5 feet of insulation everywhere, and it's great, but there's a limit. I mean, you have to look at
I can't have the ground stealing my heat, so then I have to insulate underneath.
Yes, but it might be better, rather than digging it all out and going underneath, to do what I did with my greenhouse. I put 4 inches of insulation just right on top of the ground, and then I put my sand on top of that.
Yeah. Plus, we have also a very high water table. If I dig a 4-foot deep hole, I'm going to have water in there, and I'll never be able to keep it dry.
Enemy. Water's a big enemy for that. We have that same issue here.
Okay. So basically, that's what it looks like when it's finished. I'm building a fully fledged product. It's buried up until that line, and it's got lush green jungle in the greenhouse. I might need to use a double greenhouse because it's so cold polycarbonate, that even 3-walled polycarbonate, I don't think it will sustain it. And you're obviously aware of the Chinese greenhouse. I think I've seen something on your channel.
I see right there, you're talking about thermal blankets, and that's the best way to go. As soon as you go with polycarbonate into 3 and 4 and 5 layers, you lose 8% of your sunlight for every layer of polycarbonate. So it's not really that smart to go beyond double polycarbonate. Glass is great. You can do as much as you want, but of course your cost is going to go through the roof. People go, I can get free glass. Yeah, but you got to frame it in. And the framing's not cheap when you come to glass too, because it requires a lot more in framing.
Exactly.
So whether it's a poly, that's an air inflated poly, which is by far the cheapest way to go, or polycarbonate, which is a little more money, the thermal blanket is, in our climates, it's absolutely one of the most not considered and important things that you need to have in a greenhouse, especially if you can have it on the inside.
The blanket. Yeah, of course, because otherwise the snow is going to completely jam the whole system.
There's a guy in Saskatchewan named Dong, a Chinese guy. I don't know if you've seen any of his stuff. He does huge Chinese greenhouses.
In Canada.
Yes. And it's beautiful.
He's got a little
system on the inside.
He's got a little vibrator to shake off the snow.
Yeah, that was cool. That was really cool what he did on that. But outside of that, I mean, I can always scrape the snow off when it comes. I love how he put his insulating blanket on the inside. I don't know if you remember
Yeah.
seeing that or not. It's
So
genius.
besides the cold tech, I want to be able to build the vaults, the vaulted roofs using augmented reality. It's the program is called Hologram. They're basically the
Okay.
guys are putting the glasses on and they can see where exactly to put every single brick. That way
That's
we can
cool.
build our homes without using formwork. And this is the future of how I see the biotecture, organic liquid bioarchitecture with
That's
greenhouses
cool.
that stick out of these all these big openings, and they're extremely strong. The guy's putting in 4,500 kilograms on
I
one
believe
square
that. Just
meter.
my experience with my dome teaches me that. The domes are incredibly strong.
Yeah, yeah. So yeah. I wanted to share that with you. Um,
So a
what
couple of
other
the things, I guess, outside of
yeah?
insulation that I wanted to discuss is what are you doing for water collection?
Okay, so the water collection. This is what I'm thinking. Okay, so the Earthships have these very expensive metal roofs. And I just thought again, I want to go low tech just like yourself. So I thought, oh, if we have a grass roof, okay, which is
Mhm.
just like a hobbit home. Okay, it's flattish on top, so I can build in a ridge inside, and underneath the grass, I want to have the waterproofing barrier like a plastic, something cheap, 3 layers. I'm very inspired by John Haight's book. I think I've sent it to you. Please have a look at it. It's incredible. It's the umbrella home. Okay, so basically it's a layer of plastic insulation, not thick. Layer of plastic insulation, layer of plastic. So even if one layer of plastic gets torn, then there is 2 more. Okay, so that's keeping the whole thing dry. Now, what I'm going to do is I'm going to put sand on top of this, which acts as a natural filter, and then I'm going to put the grass turfs on top of that. So obviously not in winter, but in summer and autumn and spring, when it's like there's a lot of moisture and water and rain, because the sand is got air particles, so it's less dense. I'm hoping that as the water gets through the turf, which is already acting as a little bit of a cleaning mechanism, the sand gets through the sand and then it gets cleaned out. And obviously, behind in my burial, in the coldest part, I'm going to have a water tank. And the cheapest water tank that I've learned that you could do, because obviously anything you bury has to be this proper water tank, which is expensive. But you can use a standard plastic cylinder tank if, when you bury it around, you put soil around it, and then you mix cement water and you pour around that and you just do a little compaction. So this cement water binds, and it's called stabilized earth. Maybe you've heard of the
Yeah,
term.
I have.
And basically, just half a meter or 2 feet around this cheap tank, 2,500 gallon, 10,000 liter tank, you basically sprinkle the cement water and you go up every 1 foot at a time, compacting. And that thing, if that water ever gets empty, the tank will not implode because you have a stabilized cylinder.
Right.
That's my thoughts. And obviously, from that is a standard Earthship system, which is a delivery to a water organizing module, which I'll send you the lesson. I've made it already. It's very cool. It's 12 volt, got a couple of filters on it. And then I've got a fantastic biochar filter that I've learned in Thailand from an American PhD guy called Josh Kearns. And biochar, we made our own biochar. First tank is gravel, cleaned, washed. Second is sand, but big quantities, 100 liters. 100 liters of sand, clean, washed, and 100 liters of biochar, clean, washed. Scott, the water coming out of the other end, I had it tested. It was 200 times better than standard city quality water. Biochar filtration.
That's fabulous. I mean, the first thing I've always thought, and I got, how do I say this? I got my ass handed to me by a couple people in my comments when I talked about this, was why don't they just use a well? And I didn't realize that people don't have access to wells like we do here where I live. If you have access to drilling a well and it's under 200 feet, my opinion is don't bother with any of that crap. Drill the well. It's on and off. It's tap water. I mean, just put a filter on it. You're done. But there's a lot of places that isn't a possibility. They got to go 1,000 feet or more, or it's just not there. And the cost of those wells is absolutely phenomenal. So then it falls back into what you're talking. So my only advice in looking at it from that standpoint is, if you can drill a well under 200 feet, do it. If you can't, then this is how you go forward with it. Does that make sense?
Yeah. So Scott, just I was also looking at a well with a borehole pump. That's what it's called in South Africa. It's like this diameter of 6 inches or so. And I thought it was going to cost me about $2,000, but it's actually going to cost me $10,000. And I thought, nah, not right now.
That's about right.
I'm going to do a 5 meter, 15-foot well. It's those big concrete rings. It's not really a well. I mean, what is it called? It's that old school thing that they used to do in the village days, like 200 years back.
I don't know if there's a term for it, but they call them wells as well.
They call them wells as well, but it's not that. It's not this size. It's about probably about 4 foot, 4 foot or 3 foot wide. You can climb in it. Thing. Yeah, and those things only go about 15 foot at tops. But actually a bit more, you guess. It depends what area you live in. But that water is not drinking quality sometimes, because especially if you're in an area where there's lots of other homes, everybody's pooping in their septics and so on and so forth. But I can build with that water, and I can use it for technical purposes, like whatever. But the drinking water is what I spoke of. Just then I need a much smaller tank, because that's just drinking, cooking, and maybe even washing. So that's
I'm with you. And basically you're following a lot of what the Earthships do outside of using this umbrella home system, which filters it a bit better, obviously. That works. What do you do with wastewater? Like, are you recycling it at all? You're pushing it into the food supply. There's been a lot of talk.
Just Scott, repeat your question. What I do with
wastewater, septic?
Oh no, that's an Earthship system going to be. The septic, I'm going to use a cheapest septic that I've done, and I'm doing everything super cheap and low tech, just like you. The cheapest septic is using truck tires, Earthship style, big bus tires, big. Okay, probably about 4 foot diameter, 3 foot, massive. Okay, and then there's about 5 of them in the plastic lined well. Okay, and then with some rocks around that, and then basically the pipe goes right through in the middle, and then you put a little ferrocement dome, and then pour straight slab, and then the toilet goes straight on top of that. Okay. And that's a septic. I might add a bit of oxygenation, but that's a separate story. And that goes through a botanical cell in this greenhouse behind me. So the plants such as bulrushes and other water plants are going to clean that water up. And I have had good experience in South Africa, not in cold climate, in South Africa, with getting my water from septic. In fact, biogas, a biogas digester. I had the fire going. And then from that biogas digester, I had the water, I stuck my hand in it, there was no smell. It was a 14-meter long, about 40-foot long wetland, botanical cell that I made. Yeah, it worked. Amazing.
Those are cool. We don't get into a lot of septic with the greenhouse side. It's more just the water for watering and going forward. But I find that interesting to look at how different people approach that and go forward with it. I live in a rural area where, you know, the 2 main options that we have for septic here are either holding tanks where a truck comes and pulls it out, or a septic field. And I mean, the fields work better with an aerator, like you had mentioned, if you have on your pre-tank, a way to push that. Although there has been a couple issues with smell. Like I have an RV park, and everything here, because of size and what we're doing, is all tanks that are hauled out by a truck, but it's hauled to a municipal place that then biologically aerates it and processes it before it puts it back into the natural environment.
Yeah, so the problem with just putting it into a leach field is that in my case, in an Earthship case, the plant's roots in the gravel get into contact, and the water goes through, and actually there is no smell. If it's sized correctly, there is no smell at all, because the plant's cleaning up the water. The leach field literally drops it onto a field through lots of.
I like that idea. That's really cool.
Yeah. So I'm in essence building an academy of bioarchitecture that I can invite kids and teenagers to come and experience how nature treats our water and heats our homes up using no fireplace. I'm really aiming to try and get these homes to operate in Canada with no fireplace at all.
I like that. Don't get me wrong. I think you're on the right path. I think that compared to Earthships, you're exponentially making a much better system. You're approaching it right. I get what you're saying about California. For Californians, the eco seems to take precedence over ROI in all cases, and that's all they think about. You walk out of California, and the rest of the world doesn't really think like that. I mean, you've got to have something that's affordable and usable and available in your area. And what you're doing with the earth bags, I love it. I mean, I follow a couple called the Green Team Project or something like that in Arizona that built an earth bag home, and I love watching their work. They built this huge cistern. I don't know if you're familiar with them or not, but
yeah,
they've done some really cool work in how they've worked with earth bags, and you're on the right path. I really think you're on the right path on how to develop that. I wonder myself, and I've seen things similar but not quite, if it's possible to actually make a simple machine to fill earth bags or earth bag tubes that might work even better with what you're doing. I understand this is more technology, but it's simple technology.
I've seen a machine online on YouTube. I'll send you the link. Maybe we can put it into this video. But basically, has it's like a little truck that scoops up this mix, and it has like a auger screw thing, and then the sandbag is put to the side and just shoots out sideways. Sandbag method can be sped up if it has a little stand with two wheels. That I'm sure you've seen those guys with red Hyper Adobe bags. Hyper Adobe doesn't use barbed wire. Super Adobe with white polypropylene bag uses barbed wire, so it's an extra step. But it does take quite long, Scott. I do think the future is in 3D printing the walls, because the printing happens in two walls side by side.
Yeah,
so
I've seen machinery that does that, and it's fabulous in what they're doing.
Yes,
but expensive.
So the walls that we need to transfer mass through the laws of thermodynamics, we fill them with with mass like sand, okay, or a bit of stabilized earth or clay, and stomp it 10 centimeters at a time, so don't pop those walls up, okay. But the walls that we want to stop the transferal of heat, we will put that polystyrene, aircrete mix, or whatever insulative we can find. But there is one more technology that we didn't speak of, and that is, I actually want to jump onto my other computer and show you quickly a wood chip using Jean Payne's composting method.
Oh, I love this. I'm actually planning myself to get a wood chipper for my tractor next year. The amount of heat you can get from these type of systems is absolutely fabulous.
How much heat?
My understanding from what I've looked at, and I haven't built one yet because I'm waiting, hopefully this year I'm going to get a wood chipper for my tractor. I've got a Kubota. Is that they're going to produce 140 to 160 degree Fahrenheit heat with a large pile. When I say a large pile, I mean 20 yards or more. And it should do it for about a year, at least a year, which is beautiful because in a climate like ours, you can put it together in the fall. What's nice is if you're cutting firewood, there's so much branches and extra that's just wasted, and it's usually just burned in a burn pit or something like that. And this can all turn into heat. The other thing that, from my understanding, the science of it when looking at it, is that you can get more than twice the amount of heat out of a piece of wood if you compost it versus burning it. And I know a lot of people are against burning and going on there. Whether you burn it or compost it, you're going to release the same amount of carbon dioxide back into the environment. But the reality is, it comes back with other trees. So it's a slower green. It's not the same as burning fossil fuels that are coming out of the ground. It's they don't really consider burning firewood all that terrible for the environment. But
yeah, but you know what I heard? You can actually get the same amount of temperature and heat for the same duration if you compost the stuff versus just burning it. But the main difference is that at the end of the cold season, you either have a pile of ash, which you almost can't do anything except spread on potatoes.
Then you've got extremely valuable compost. You can use it,
Extremely
or you
valuable, and
can
you have a
sell it.
lot of it, and a lot of it. So,
Yeah.
so this is the home that I wanted to share with you. It's my latest design, and I'm just left my chair. So I'm just, can you see this?
Yes.
Yeah, so basically, I know it's a bit funky. I'm actually designing a school for children, and I thought I'd design it really in a different place, in a different, like more or funky place. Design. So it has a
That is
large
cool.
large greenhouse with lots of plants that are able to grow here, and that's a walkway. Okay, let me just add a bit of show a bit of color. Then that's this method I showed you out of wood that I built in
Oh,
that
wow.
northern, very cold -30 area. So those wooden strats, like
Yep.
I'll show you a picture again just now. And basically this is the composter. This is the compost, and I've made it in a way that it can be easily accessed. So if you need to get it out with maybe if you have a little machine or you don't, or you have a little pickup truck that you can load compost. But let's use wood chips. We'll need to throw some maybe a top with some because wood chips are already insulated. But basically,
Wood
they're going
chips,
to
a
be
little manure, mix it up, put some pipes in between it,
it's,
and you're laughing.
maybe not even mix it up. Maybe just throw it in layers, just in layers, like 1 foot of this, 1 foot of that, 1 foot of this, and then throw a little warm blanket, waterproof blanket, and that
Yeah,
goes
it'll work.
through. But just by touching this wall, it's going to transfer heat into this space.
See, there hasn't been
That's
an
not
enormous amount of research in the John Paul stuff, but so it's something that I want to do myself. But what I love about it is if you feed that into a radiant floor, it's coming in at right around the temperatures you want your radiant floor to be at. You know, if you're using a radiant floor like I'm doing right now with a wood boiler, the floor gets, it's fine for a greenhouse, but it gets too hot for a human to walk around sometimes. Whereas, you know, the 140, by the time that dissipates out, it's for heating with a radiant floor.
okay. Okay. So what you're saying is by having a good temperature inside of our system, it can be the same similar temperature to our to a comfort temperature that we need.
Yeah. That compost pile, it's absolutely genius, and it's a wonderful, wonderful way to heat. And I'm going to tell you, as someone that's heating with wood right now, okay, wood is nice, and I get a lot of good exercise out of it, but it's a lot of work. I'm actually putting up a video. It's almost done. I don't know which one, if I'll get this one or the other one first. That shows how much work I have to do on a weekly basis to feed my wood boiler. I got to stuff it 2 to 3 times a day. I have to cut all the wood. I have to bring the wood here. I have to dig it out of the snow when the snow comes on it. Then I got to chop it down. There's a lot of work that's involved in the wood boiler. You got to take the ash out of the wood boiler every 2 weeks, which is a lot of work.
Are you aware of the
compost
system?
pile.
Are you aware of the system called Ondol floor? South Korean or South Korean Ondol system. So they use these wood channels. Let me see if I can pull a little picture.
Those were fairly ancient too, weren't they? A couple 100 years old.
Yes, very ancient. But the beauty is, listen, you're gonna fall off your chair now. This guy, in northern climate, -20, he claims that once you heat this thing up, it's going to pop up on the screen now. Once you heat this thing up, Scott, he only stokes the fireplace every 2 weeks. Every 2 weeks.
Taking a thermal mass to the extremes of what it can do, and I like the idea. I mean, it's not about just generating the heat, but it's also about being able to store it and use it effectively.
Yeah, and I know what you're talking about, this metal wood boiler. We're stoking ours every 1 hour, okay? Because it's metal. Yeah. It's metal, and it's so inefficient. We right now, and it's not our home. So, but the bottom line is that every 1 hour, I'm piling that thing full of wood. It's eating from morning until night. And morning time we wake up, it's cold again. It's just so inefficient because there is no mass. And having no mass.
Well, the next question is, what kind of wood are you burning? Because I've gone through this and I find that, well, right now I got access to some oak. Oh my God, it changed my life. When I was using things like, I was filling that damn boiler every 3-4 hours. It was terrible. With oak, I can do it twice a day. And a lot of it comes down to the type of wood that you can get. Now, not a lot of people want to give you access to oak, But I got really lucky because a local farmer, we went through a drought for 2 years and had a big section of oak trees that all started dying going at the center. So they weren't really good for anything else other than an outside wood boiler. So I got very lucky with that. But I tell you, I don't ever want to use anything but oak or oak equivalent type hardwoods that have that kind of energy density to them. Because when I use other types of wood or smaller pieces of wood, like you're saying, I'm stoking and I'm putting wood into the thing constantly. But when I put big chunks, and when I say big chunks, I'm talking logs that are at least a foot across and 3 feet long. I'm only doing it twice a day, and I like that.
Yeah, so this system is called Ondol, Ondol. Okay, and it has a thick floor.
It's almost like a rocket mass heater.
Yeah, but it heats up the entire floor through those channels that you've seen. I mean, you can do those channels out of bricks. You can do them out of sandbags. Yeah, so that's something we're going to be playing around with. So I want to do your type of radiant heater system on the with radiator in one room, and I want to do this Ondol system in this one of the main rooms.
I'd love
and
to see that in
just test. I'm going to be the guinea pig in this because I don't have all the answers, just like you, with trial and error.
Yep.
Yeah,
that's a beautiful system in what you're looking at there. I mean, I like it's almost it's using like a rocket mass heater. It's turning the floor into the big mass for the rocket mass heater, and it's smart. I'm just worried with that. The only concern I have with that is the floor going to get too hot?
If you
and that's something you've got to get into it.
If you overstoke it, okay, because you can give it power and keep on heating it and heating it. Yes, it can get very hot. It won't be so hot that it starts burning the wood, but it'll be it'll be too warm. It'll be too warm because the law of thermodynamics, mass heats mass.
Yeah.
So the air might be cool, but your body's cells start warming up.
Which is one of the reasons why I love the compost pile, because it gives you a steady amount of heat. And when you have a fixed amount that stays steady 24 hours a day, it's nice. It's easier to manage with a thermostat because you just turn on and turn off the pumps for have that fairly cheaply automated to give you the right temperatures you want inside, especially for a home. For a greenhouse, you can have a little more variance, but for a home, people, they don't want to have big shifts in their temperature.
So there's so much to try, but I'm building 2 rooms this summer. This green room behind me, that one, the main one, out of wooden slats, and one side room which is going to be a ferrocement, just a sheet of metal as a formwork. And then I'm going to try 2 different methods in 2 different rooms. So it's really great.
I'm going to be following that. I'd love to see that.
Yeah. Yeah, and I think we should do another call where we can discuss those other questions that we didn't touch on. But right now, it's been good to just share about the thermodynamics.
I'm really happy you reached out and got a hold of me. We should get back in touch probably in the fall when we've played with a few more of these things, and we can talk a little more in depth of what we've done and where we've gone with them.
That'll be lovely, Scott. Thank you so much.